Welcome back to the continuation topic of vectors, that is resolution of vectors. But what is resolution of vectors? A vector can be divided, a vector can be split along x axis, along y axis. So, along x direction, along y direction, if the vector influence is there, you can show that influence of the vector along x axis and y axis with the component of vectors. Such a process of dividing of a main vector into its components along x axis and along y axis is called as a resolution of vectors. But what is the purpose of this resolution of vectors? See this, if you take one example, say this is force vector, say this is force vector. For example, I am taking one car, a toy car, and I am tying it with a rope and I am pulling that car in this direction by applying a force of F newtons. So, force and a vector represent chestunam. So, we are using a force vector here. Now, if you see this car is lifting in the air. So, I think you played with the car in the childhood, tying a rope to the car, applying the force on the car with certain angle. So, same diagram I am representing. So, whenever your car is lifted into the air like this, the influence of the force on the car is acting somewhat along x axis and some amount of force on the car is acting along y axis. So, whatever the force which is applying on the car is acting somewhat along x axis or x direction and remaining force acts along a y direction or a y axis. That is why a vector has its influence along somewhat x axis, along somewhat y axis. That is why we can divide a main vector into its components along x and y directions. We call such a concept of dividing a vector, its influence along x axis and y axis is called as a resolution of vectors. For example, in this diagram, if I am applying force on the car with an angle say theta, with an angle say theta. So, with a theta angle I am lifting the car with the help of a rope and this theta indicates with what angle we are applying force on the car, right. Now, with the help of this theta, with the help of this main vector concept, we will see what are the components of vectors. We will see components of vectors. What are the components of vector force along x axis and along y axis. So, x axis lo force enta act avutundi, y axis lo force enta act avutundi. We call that influence of force along x axis and y axis are components of a vector force. So, what is the x component? Along x direction, what is the component of a force vector? So, our example vector is here force. So, we are going to find what is the x component of force vector along the x axis. For that, we need a small geometry. Now, draw one perpendicular line to the x axis connecting the force vector. So, we are drawing one perpendicular line. So, now it is looking like a right angle triangle. If this is angle theta, you know this is perpendicular angle, this is 90 degrees and you know the remaining angle with theta 90 degrees is 90 degrees minus theta. So, this is the geometry in our obtained triangle. Now, what we need? X component. We need this x component. For our theta, if you see, the direction of our s component is nothing but base of the right angle triangle. So, base of the triangle is nothing but here adjacent side. So, this is adjacent side and our force vector is represent along hypotenuse of our right angle triangle. So, this is hypotenuse, that is force vector direction, and whatever we are going to find, that is x component, it is acting like a adjacent side. So, here we need to find one adjacent side with the knowing value, hypotenuse value, that is force vector. So, what is the formula we can use here when we have an adjacent side and we have a hypotenuse? Of course, it is cos theta. So, to find out the x component of force vector, use the formula cos theta. So, cos theta is equals to base upon hypotenuse. Base upon a hypotenuse or adjacent side by hypotenuse. So, from the equation, from the diagram, what is the base? Base we have to find out. Say that is x. So, whatever we are finding along x axis, that is taking as a x. And what is the hypotenuse? It is equals to our force vector, that is a f. So, now you have to find out this x. So, keep x here and send this f vector to the left side. So, it becomes vector f cos theta. So, this is the x component or force component along the x direction. So, what is the x component or what is the force component along x axis? It is equals to f cos theta. If you want, you can write like this also, f x cos theta, which means this is the force component along the x axis. So, f x cos theta, or simply you can write it as a f cos theta. Clear? Now, we want to find out what is the influence of this force vector along y axis or y direction. Now, what we have to do is, again we have to draw one perpendicular line to the y axis like this, and again we are making one right angle triangle. If you say this is the angle 90 minus theta here, if this is the angle 90 minus theta, what will be this remaining angle? How much angle will be remained here? It is equals to theta. So, totally here it is 90 degrees perpendicular angle. Out of 90 degrees, here we got 90 minus theta and remaining value will be theta, right? Geometry of the triangle. So, it is theta. If that is theta, and this is 90 degrees and remaining angle here in the given triangle is 90 minus theta. Clear? Right. So, now see the diagram. This is theta, and what we are going to find out now, what is the force vector along a y axis or y direction. So, this is the question mark here. So, what is this side to the theta here according to right angle triangle? To this theta, this side is nothing but opposite side. So, this is opposite side and we know the hypotenuse, that is equals to our force. So, you want to find out opposite side, you know the hypotenuse. Then what is the best formula we use to get it? Sin theta. So, sin theta is equals to opposite side by hypotenuse. So, what is the opposite side here? We have to find out, say along y direction it is taking as a y, by what is hypotenuse? Our force vector, vector f equals to sin theta. Then what we have to find out? Why we have to find out? What is the component of vector force along a y axis or y direction? So, y is equals to force vector into sin theta, or you can take it as fy sin theta. So, what is the force vector we got along a y axis here? It is vector f sin theta. So, f sin theta is the force component along a y axis, f cos theta is the force vector along a force component along x axis. So, in this way a vector can be resolved into components along x axis, components along a y axis. Or if you have any confusion where to take cos theta, where to take sin theta, see here, wherever the side you get the theta here, directly blindly you can write it as a cos component, means cos theta component we will get, and opposite to that, opposite side or perpendicular side to that of theta, we will have sin theta component like this. So, here we have a theta, we will get cos theta, and we have a geometry proof also for that. So, f cos theta and f sin theta are the components of our force vectors along x axis and y axis. Now, let us do one small example for it to understand this concept. let us take one small example. Let us take one small example. I said I am applying some force on the car now, right? Example, say this is force vector. Say I am applying 10 newtons of force on the car, right? And we have the components of vectors. Force vector along x-axis, you know, that is f cos theta, and say the angle which I am lifting, with what angle I am lifting the car into the air with the help of a thread or a rope, is say 30 degrees. So, with 30 degrees angle I am lifting the car and applying a force of 10 newtons on it. So, the force which is acting on the car will be have its component along x axis, which is equals to f cos theta, and it has its component along a y axis, that is f sin theta, right? Now, we can find out what is the value of f cos theta. We can find out the value of f cos theta here. For example, fx. What is fx here? Fx is the force vector along say x axis, which is equals to, what is the force vector along x axis? You know, that is f cos theta. And what is the force acts along y axis? Say that is fy. So, fy is the force vector along y axis. Say fx is the force vector along x axis, that is fx is equals to f cos theta, fy is equals to f sin theta. So, this is f sin theta. Now, substitute the values. You know the force, how much we are applying on the car, which is equals to 10 newtons into cos. What is the theta acting here? Theta is equals to 30 degrees. So, what is cos 30 degrees? 10 into, what is cos 30 degrees? Sin 30 degrees is equals to 1 by 2, 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Then what is cos 30 value? Root 3 by 2, root 3 by 2. So, cos 30 degrees value is equals to root 3 by 2, 2 ones, 2 5s. So, we are getting 5 root 3. So, what is the force vector value acting along x direction? That is 5 root 3. In the same way, along y axis, what is the force vector component? F sin theta. So, force value is again 10 newtons into sin 30 degrees. So, what is sin 30 degrees? It is equals to 1 by 2. So, 2 ones, 2 5s. So, what is the force vector component we got along y axis? That is 5 newtons. So, this is 5 root 3 newtons. In this way, we can have an example of resolution of vectors. What is the component of a main vector along x axis, along a y axis? Thank you.